All right, so this section is about ratios. So we're going to look at ratios, and they can be written either with colons, as in 1 dash or 1 colon 2, or as a fraction like 1 over 2. So both of these are acceptable ratio ways of writing ratios. So first of all, we're going to look at an example here with a bunch of colored squares. And we're going to look at writing a ratio for the number of red squares to the number of blue squares. So the way ratios work is you look at the first thing that's being asked. That will be the first number in the ratio. And the second thing that's being asked will be the second number in the ratio. So if I look at this diagram, the number of red squares I can see are 2. So I would write 2, because there's 2 red squares. And we'll use the colon type. And to the number of blue squares, I can see 1, 2, 3, 4, 5, 6. So it'd be 2 to 6. Or we could write that as 2 over 6 as a fraction. And of course, we can reduce those, but we'll look at how, why we would want to reduce those later. But typically, you would want to reduce these. But for right now, it's kind of a nice, it's a nice option to have all the number of squares that we have, like the red and the blue. Part 2 here, write a ratio for the number of pink squares to the number of total squares. This time, the first thing that's being asked is the pink squares. So I can see I have 4 pink squares, and I'll use the colon again. The number of total squares, again, now you have to add them all up. So I know there's 1, 2, 3, 4, 5, 6. So that's 12 for the blue and the yellow. Or you could just add them all separately. It's fine. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 4 to 24. So like I said, the first number, 4, represents the pink. And the second number, 24, represents the total. And of course, we could write that as a fraction as well. 4 out of 24. And you could reduce that. But for this question, I'm not going to reduce them because it's kind of nice just to have them as they are. So that's the first example. You can write ratios in lowest terms by reducing the ratio just like you did when you reduced fractions. So when I have a ratio like this in example 1, 4 to 16, we say 4 to 16. And we can divide both these by 4. I can divide that by 4, and I can divide the 16 by 4 as well. So what I do is I divide them both by a greatest common factor, find out what the GCF is. In this case, the GCF is 4. And then you divide both the terms by that GCF. So you get 1, and 16 divided by 4, of course, is 4. And you should know how to reduce fractions, I think, by now. So if I look at 6 and 14, GCF for this one would be 2, because 2 goes into both, 3 doesn't go into both, and 6 doesn't go into both. So we're going to divide both the top and the bottom. I said 2, not 3. Divide both the top and the bottom by 2. So I end up getting 6 divided by 2 is 3. 14 divided by 2 is 7. So I end up with an answer of 3 over 7. Okay, the first one was 1 to 4. Last one here, 5 to 30. Of course, these both have 5 common, so you divide both by 5. So I get 1 to 30 divided by 5 is 6. So I get a lowest common ratio of 1 to 6. So we reduce them. So from above, we can see which ratio are written as unit ratios. So in this case, 1 to 4 would be a unit ratio. Why? Because it is in terms of 1. We have a 1, we can see the 1, therefore that's a unit ratio. If we can get one of the numbers on the left or right to 1 by dividing, then we get a unit ratio. This one is not a unit ratio. And the last one, of course, is a unit ratio because of that 1 again. Okay, so unit ratios are very important, and we'll see how they work now. In this example, a natural food store makes its own trail mix. For one variety, they use nuts, dried nuts, and candy, chocolate candy, in a ratio of 12 to 9 to 4. So, and this is in the mass in kilograms. So what comes first? They use nuts. So this would be the amount of nuts used. The middle number would be the amount of dried fruit. I'm just going to write fruit. And the last number would be the amount of candy in kilograms as a ratio. So we're going to see, what is this ratio of the fruits to nuts in lowest terms? So first of all, I have 12 to 9 to 4. And I have to figure out what the GCF is here. What is the greatest common factor between all of these numbers? 12, 9, and 4. Let's see. 12 and 9 both have 3, but 4 does not. And 9 can't be reduced. So this is actually in lowest terms already. There's no GCF. Therefore, this is already in lowest terms. Section 2, or question 2 of the same, using the same example. So a customer comes into a store and wants the ratio to remain the same. So they want 12 to 9 to 4. Remember, that's nuts. Just to remind ourselves, 9 was the fruit. And the last one, 4, is the candy. So less candy, more nuts, and a little bit of fruit. A customer comes in the store and wants the ratio to remain the same, but wants 12 kilograms of candy in the mix. 12 kilograms of candy, that's the last term there. Okay? So we want that value to be 12. How many kilograms of nuts and dried fruit are going to be in the mix? So now the ratio is going to be, we have to figure out the number of nuts, 2, the number of fruit, 2, the number of candy is told to us to be 12. Okay? So what we have to do is we have to look at our original ratio. I should have actually written this below, so I'll do that now. So we start off with our ratio 12 to 9 to 4. And we want a ratio of something to 12. So from the last value, the number of kilograms of candy, I try to ask myself, what did I multiply 4 by to get to 12? Well, that's multiplied by 3. So in order for the ratio to remain the same, we need to multiply by the same value for each of the numbers in the original ratio. So 12, we're going to multiply that by 3 to get 36. And 9, we're going to multiply that one by 3 as well, which is 27. So I get 36 to 27 to 12. So multiplying all of them by the same amount. But first of all, we had to basically figure out what we're going to be multiplying by. And make sure that you keep it in the same order. Nuts to fruit to candy. If the store, part 3, makes 150 kilograms of mix in a month, how much of each ingredient do they need? Okay, so this is a bit more complicated because first of all, with that initial ratio, 12 to 9 to 4, we have to figure out what the total is, the total amount of kilograms in this entire mix. So the total, how we find that, is we add them all together. 12 plus 9 plus 4. Okay? So 12 plus 9, we can add these in our calculator if you need to, it's totally fine. 12 plus 9 plus 4 is 25. So in this mix, we have 25 kilograms total of all the stuff. 12 kilograms of nuts, 9 kilograms of fruit, and 4 kilograms of candy. But we want 150, okay? We want the total to equal 150. So this time we just see what do we multiply 25 by to get 150. And you can do that by dividing 150 by 25. And we see that each one was, or the whole thing, the entire total was multiplied by 6. So then we go back to our original ratio and we multiply each ratio or each value in the ratio by 6. Okay? I'm not going to use arrows just because it will make it messy. So 12 times 6 is 72. 9 times 6 is 54. And 4 times 6 is 24. And you can check this. We can double check this to make sure everything adds up to 150 because it has to. So 72 plus 54 kilograms of fruit plus 24 kilograms of candy. And that indeed does equal 150. So this is the new ratio of mix. So we're going to need 72 kilograms of the nuts, 54 kilograms of the fruit, and 24 kilograms of the candy. Okay, moving on to this last part of this. So ratios can also be written to compare 3 items, which is what we just saw. A company makes fruit smoothies using a ratio of 4 to 3 to 8. Again, I'm just going to reiterate this using like 3, because the 2 ratios are fairly simple. We already went over those. And this is fruit puree to yogurt to milk. So of course we have the fruit, the puree, to, what was the middle one? Yogurt. And then the last one, the 8, represents the amount of milk. So from this ratio, we can write other ratios we've already seen this in the last example as well. However, now we're going to take this 3 ratio and we're going to take all the pieces that we need to write a 2 ratio. So we're going to say, what is the ratio of milk to fruit, or to fruit puree? So I look up here, milk was 8. That comes first. Remember, 2 means I'm going to be writing my ratio, my colon. So 8 to fruit puree was 4. So this ends up being 8 to 4. If the store, this is just like the last example, if the store, so we're going to use our 4 to 3 to 8. If the store makes a total of 4,500 smoothies, oops, I used to disregard that of. If the store makes a total of 4,500 smoothies in a week, how much of each ingredient do they need? So again, we're going to do the same thing where we have a total. The total for this ratio is 4 to 3 to 8. So we're going to add these all together, 4 plus 3 plus 8. So 4 plus 3 is 7, plus 8 is 15. We want a total of 4,500. So this ratio, if I just kept it all, this ratio would make a total of 15 smoothies. So 4,500 divided by 15, and that's equal to 300. So I'm multiplying this ratio by 300. This is kind of how you would do recipes as well, if you're increasing the amount of, each thing in a recipe you need. So we're going to multiply each one of these by 300. So 4 times 300 should be 1,200. 3 times 300 should be 900. And finally, 8 by 300 should be 2,400. Okay, so from a 3 ratio, a ratio with 3 numbers, we can now write a ratio with 2 numbers. We can write ratios because we know what comes first and what comes second, or what comes third too, if we write a 3 ratio. We know how to increase ratios, how to write unit ratios for questions. So hopefully that helps.